Hello everybody and welcome to section 3. After we know how to create sketch entities, it's the time to talk about sketch constraints. Let's have a look at this line. This line is free to move. If I drag this point, it will move. If I drag this one, it will move. If I'll drag the line itself, it will move. Our task will be to eliminate all the movements that this line or any 2D sketch entity can perform. So we have what we call a fully defined sketch. If we have a look here, you'll find Underdefined. After we define what we call constraints, this will be turned into what we call fully defined. There are two types of constraints: geometrical constraints and dimensional constraints. We will talk about both of them. As an example, this is the origin point, so we need to relate this line to this point. You don't need to work with me now, but I will just show you the principle. Let's consider this point. We can move it in the x direction, and we can move it in the y direction. To eliminate this movement, we need to define a distance in the x direction, and now it doesn't move in the x, as you can see. It only moves in the y direction. That's why if we define a distance in the y direction, then this point cannot move. But we still have this point free to move. As you can see, this point is black now, which means it's a fully defined point. I'll treat this point the same way I treated this one. So I will define two distances. And now the whole line is black, which means it's a fully defined line, and you can see this here. And we can tell that because it's black. So whenever you have a black entity, it means it's a fully defined entity. And whenever it's a blue entity, it's an underdefined entity. This is the first type of constraints, which is dimensional. Now let's talk about geometrical constraints. Some kinds of geometrical constraints are horizontal, vertical, coincident, perpendicular, parallel, and so on. For now, if I select this line, I can set it to be horizontal. Now I have this symbol here, and that means this line will be horizontal all the time. This line, I want it to be vertical, and now it will be vertical all the time. I can join these 2 points, and now they will be connected all the time. I can set these 2 lines to be equal, and now their length will be the same. Then I can set this point at the origin, and finally I can give this a length. And now I have fully defined entities. So this is a quick preview in what we will be doing during this section. Next, we will talk about vertical and horizontal constraints. Horizontal and vertical constraints. Let's start with a sketch on the front. If I have a line, I can set this line to be vertical or horizontal. To do so, you just need to select the line, and then you will have this menu here. You can select horizontal or vertical or fixed. Alternatively, you can select the line and you can use this menu here. So for now, I want this line to be horizontal. If you have another line, you can select it, then you can set it to be vertical. If I want this point and this point to be on the same axis in this direction, in the vertical direction, simply select this point, hold Ctrl and select the other one, and then select Make Vertical. Now if you try to drag any of these lines, this relation here will be maintained, and we have the symbol to tell us that these 2 points are vertical. Try to move this one, for example. They will be all the time together. Now, I set this line to be horizontal. I will select this point with this one and set them to be vertical. Now, this line will be horizontal all the time, and these points will lie on the same axis all the time. Try to drag it. And for this line, let's set it to be vertical, and select this point, hold Ctrl with this one, and set them to be horizontal. If you try to drag it this way, it will maintain the relation. Next, we will talk about other relations, parallel and perpendicular. Parallel and perpendicular relations. When dealing with lines, the constraints we have are not limited to vertical and horizontal. If I have any two random lines, I can select the first one, hold Ctrl, the second one, and then make parallel. Now I have the symbol here, which means that these two lines are parallel to each other. If you try to drag any of these, they will maintain this relation all the time. Also, any two lines can be perpendicular to each other. If you select this line and this one, and then select perpendicular, then we'll have the symbol, and the angle between them will be 90 degrees all the time. Next, we will talk about midpoint and coincident. Midpoint and coincident. Coincident is one of the mostly used relations in SolidWorks to sketch. If we have these two lines, you can select this line and select this point, and here you will have Make Coincident. If you select Make Coincident, now this point will lie on this line or on its extension all the time. If you try to drag it, it will always be on this line or on its extension. And keep in mind, it's not limited to lines. If I have a circle here, I can set this point with this line to be coincident, and now it will lie on this line or its extension. If I have an arc, I can select this point with this arc to be coincident, and now this point will always be coincident with this arc or its extension. In some occasions, you will need to be able to define the midpoint of this line or this arc. If I have a line here, I can select this point and this arc, and then you will find Make Midpoint. Now the endpoint of this line will always lie in the middle of this arc. If you try to drag this, this one will be in the middle all the time. Try to drag it. It will always be in the middle. You can also select this point with this line and then make midpoint. Here, it's right in the middle. We can make this line vertical, and you can make this one horizontal. We have a lot of relations now. So this point will be always right in the middle of this line, whatever happens. Next, we will talk about tangent and equal constraints. Tangent and equal. If we have a circle right in the center and any random line and any random arc, for now I will select the circle and select fix. Later on we will talk about fix, but for now just fix this circle. Now select this line, hold Ctrl and select this circle, and you will find make tangent. Now we have the symbol here and we have it here, which means this line will always be tangent to this circle, or the extension of this line, because as you can see here, this line doesn't touch the circle, but the relation is tangent with its extension, and you can see it here represented by this dotted line. Try to drag this, and you will always have this relation. If I set this to be horizontal, now you can see that we have the tangency. You can drag this way or this way, but it will always be tangent. It's not limited to lines and circles. You can set tangency between this arc and this circle. And now this will be tangent all the time. Even when it's here, the extension of this arc will be tangent to this circle. What if you have a circle here? Then you can set tangency between these two circles. Let's draw a 3-point corner rectangle somewhere here. Then I can set this line with this circle to be tangent, and then I can set this line to be horizontal, and here you go. Another important relation is equal. You can make two lines equal, a line with a circle with a curve, a circle with an arc. Let's see this. Draw another line here, and then select the line, hold Ctrl and select this one, and here you will find make equal. Once you select it, you will have the symbol, and if you try to drag any of them, they will maintain the same length all the time. If I have another circle here, I can select this circle and this one, and then make equal. As you can see, whenever you change the diameter, it changes on the other side. You can use it with this circle and this arc. Now, the diameter here will be equal to the diameter here. We still didn't talk about dimensions, but let me show you this. You don't need to apply it. Now this is 20, so the radius here should be 10, because we have this relation. And here it's 10. If you want to double check this, this is 20. If this line is 50, this one should be the same, and here it's 50. Next, we will talk about concentric and coradial. Concentric and coradial. If we have any two circles, if you select the first one, then the second one, you can find this relation. Make concentric. Now they will have the same center. Try to drag this one or this one, they will always share the same center. Try to drag it, they will be the same. The other relation is coradial. It's more useful when having 3D bodies, but for now we will just talk about its principle. What coradial does is that it equals two circles and it makes them share the same center point. If I have this circle, I can select this one and this one, then make coradial. Here we have two circles, not one, and this is the symbol. If you try to delete this one, you still have another one, which means we had two circles. If I have an arc, then you can select the arc and the circle, and you'll find make coradial. And here you can tell that we have an arc, and then we have this circle. When it comes to coradial and concentric, try to remember that we don't select the center point, but we select the circle itself or the arc itself. If I select this arc and this circle, I can make them concentric, and here they share the same center point, but you still can control them separately. Next, we will talk about curve length and symmetric. Curve length and symmetric. If I have an arc and a line, and let's say a circle, we still didn't talk about dimensioning, but for the purpose of demonstration, I will just set a length. And now I select this line and this arc, and here you will find make curves equal length. Now we have the symbol here and we have it here, which means the length of this arc is equal to the length of this line. You don't need to do this, but just to show you that the values are the same. So the length of this arc is the same as this line. You can use it with circles. If I select this arc, hold Control, select this circle, and you will find this relation here. Make curves equal length. And we have the symbol, which means that the length of this circle will be the same as the length of this arc. Another important relation is symmetric. I'll draw a center line here, and then draw a circle, and draw another one somewhere here. Now, then select this circle, hold Control, select the line, and then select the circle, then release Control. Here you will have make symmetric. Once you select make symmetric, this one will be moved here, and now try to drag this. They will maintain the same distance from this center line. This is not limited to circles or lines. Select this line, hold Control, this one, and this one, then make symmetric. Now the distance between this line and this line, and this line and this line will be always the same. If I try to drag this, it will maintain the same distance. Now you can set these to be equal. You can set these to be horizontal. And now, if you try to drag it, they will always be on the same level. Next, we will talk about fix relation. Fix relation. It's not recommended to use this relation all the time, but if you don't want to use all these constraints, and simply if you want to have a fully defined sketch in a very fast way without worrying about the other relations we talked about, you can simply use fix relation. If you have this circle, and now it's underdefined as you can see here, if you select it, you can select make fixed, and now you have a fully defined sketch. Now you cannot define a diameter, you cannot move this circle, and you cannot relate it to other things. If you have another circle here, you can make them tangent, but this one will be fixed all the time, and this one will be the follower. Later on, in this section, we will have a practice, and you will see the difference between using fixed and not using it. Next, we will talk about dimensioning. Dimensioning. Clear the screen and draw any line, but make sure not to have it vertical or horizontal. Dimensioning in SolidWorks is really easy. Simply select Smart Dimension, and SolidWorks tries to predict which dimension you want. If you select this line and move the mouse to the right, then you will have the vertical projection of this line. If you move it down, you will have the horizontal projection of this line. If you keep it close to the line, it will give you the true length of this line. Once you click, the line will be placed. Then you can enter the value you want. If you want to change this value, simply double click and set any value you want. Now what about making this line fully defined? Select this point and select the origin point and make coincident. And here this line rotates about the origin. So to fix it, we need to make it vertical, horizontal, or we need to define an angle. If I have a center line here, I can make it horizontal. Then I can select this point with this one and make them vertical. Try to drag this now. They will be together all the time. We can define, and finally we can define an angle. So select Smart Dimension, and to define an angle, simply you need to select the first line, then select the second one, then click, and let this be 45, for example. And now we have a fully defined sketch, as you can see here, and as you can tell from the black color we have. If we have another line, we can place dimensions between points, not only between lines. So select Smart Dimension and select this point, and then set this to be 50. Once again, select this point and move the mouse this way. In this case, you will have the vertical projection and set this to be 50. It may happen that you will have the line somewhere here. If so, don't worry, just select this point and drag it somewhere above this line, and now you can place the other dimension. Finally, you can exit the Smart Dimension command by pressing the Escape button on your keyboard. Placing angles is not limited to connected entities. Like this line is not connected to this line, but we still can place an angle between them. Now, our sketch is still underdefined because we still have this point and we still can move it. To solve this problem, we need to define a length here. And if you check now, we have a fully defined sketch. In addition to length and angle dimensions, you can add a diameter and a radius. Simply select the circle, and a diameter dimension will be added. And in some occasions, you may need to add a curve length dimension. To do so, select this point, then select the arc itself, then select the end point. And here you will have this curve length dimension. As a quick practice, let's try to make this sketch a fully defined sketch. To do so, we need to place a dimension between these 2 points. And now, what's the problem? To define the problem, always try to drag any entity. Here, this circle moves in the y direction. So the solution is easy. We need to define a dimension here, and this will solve the problem. Now it's black, which means it's a fully defined circle. Lastly, we need to deal with this arc. Try to drag it. As you can see, it's free to move. So we can set these 2 points to be vertical, and now it doesn't move in this direction because these 2 points will be vertical all the time. Try to drag it, it won't go this direction. Then we can define a distance between them. And the last thing is that we still have these 2 points. If you try to drag them, it's correct, the length is 100.49, but the position of these 2 points is not specified yet. So you can select this point, and then set them to be vertical. And now we have a fully defined sketch. That's what we need to know about SolidWorks dimensioning. Next, we will talk about fillet and chamfer. Fillet and chamfer. Let's start with a rectangle. You can finish the command by pressing the escape button on your keyboard. Then I'll select this line and this one. I'll make them equal. And then I will set this to 100. Now open this menu and select fillet. The only value you need to define is the radius of the fillet. I want it to be 20. You have 2 options. The first one is to select this point. We have this message because we have a relation between this line and this line. They are equal. And this says this relation will be broken. Don't worry about this message for now. Just hit yes and then hit OK. And now, as you can see, we have this fillet. The other option is to select this line and this line. And here we have the other fillet. You can have multiple selection, like if I select this one and this one, you can create them at the same time. Now, finish the command and draw another rectangle. Something like this, and from this menu here, select Sketch Chamfer. We have 2 options here, angle distance or distance distance. We will see both of them. For now, let's set this to 15, and then the same way select this point. And here we have this chamfer, and this value is 15, which is here, and this one is 15, since equal distance is selected. You can have multiple selection, as we said earlier. Hit Ctrl Z once again and once again. Select sketch chamfer again, and this time select angle distance. Keep the same options and select this point. And here, as you can see, we have an angle and a distance instead of having two distances. Select it again, and I will remove this option, and I will set this to 20. And here I want you to pay attention to the symbol. We have D1 and D2, which stands for distance 1 and distance 2. So the first selection you create will be distance 1, and the second selection you create will be distance 2. If I select this line, and then this one, here, the first one I selected is D1, and the second one I selected is D2. This is useful when creating an unequal chamfer. Finally, you can modify these dimensions. We have equality here. They will be the same all the time. And here you can change this. Next, we will talk about offset and mirror. Offset and mirror. Let's start with a sketch on the front, and then draw a horizontal line and set the length to 100 millimeters. Here in the ribbon, you can access offset entities, and once you select it, you will have this menu here. The first parameter to define is the offset value, and here, let's set it to 20 millimeters. Then we have this option, Add Dimensions, and if you select this line, you will have the offset line here. You can reverse the direction like this, then hit OK. As you can see, we have this dimension here because if we select offset again, this option was selected, Add Dimensions. Now, I will delete this line and select offset entities once again. Set the offset value to 20 millimeters, keep Add Dimensions selected, and then select this line. Here you have bidirectional, and once you select it, you will have two lines, one in this direction and the other one in this direction. You can have a closed offset by selecting cap ends. We have two types of cap ends here. The first one is arcs, and as you can see, we have this arc here, and we have this one, and the other type is line. Then you will have it closed with lines. If I deselect bidirectional, I will only have it in this direction, then hit OK. And here, as you can see, we have the offset value and we have the length value. Let's say that we have two lines. I want them to be equal, and I want the length to be 80 millimeters. And now select offset entities once again and select this line. As you can see here, this line was selected too. Let me remove this option because I have this option selected, Select Chain. If I remove this one, only this line will be selected. Then I will need to select this one if I want to offset it. So when you select Select Chain, all the entities connected together will be selected. Let's try to have more entities. And now select Offset Entities once again, and make sure to select Select Chain. And as you can see, everything was selected. We can reverse the direction from here, and we can close it. Now you can turn the base entities to construction geometry, or you can turn the offset entities into a construction geometry. If I select base geometry here, then hit OK, as you can see, these lines were turned into construction geometry. Later on, we will see the difference between them when talking about 3D modeling. You still can modify this value here, let's say 25. Using offset is not limited to lines. You can use it with circles, and here I want a 10 millimeter offset, and I want it to be bidirectional. Then select this circle. And make sure to remove this option. As you can see, I cannot activate cap ends here, since this entity is closed. You can use it with arcs, and you can select cap ends and arcs, for example, and here's the difference. If we try to offset a rectangle, make sure not to select chain. Then you can select each side individually. But if you select chain, the whole thing will be selected at once. As you can see, whenever we have closed shape, we don't have this option activated because the shape is already closed. Now hit Ctrl A, then delete. Let's talk about mirror entities. We need to draw a center line and then draw another line somewhere here. Let's set this horizontal distance to 200 millimeters and this length to 200, and then select this point, hold Ctrl and select this one, then make horizontal. Finally, define an angle between these two lines. After that, exit Smart Dimension and select Mirror Entities. Here we have two things to define. The first one is entities to mirror, and the second one is mirror about. So I want to mirror this line, and I want to mirror it, and I want to mirror it about this line. So once you select both of them in this order, you will have this line here. And now let's double check some dimensions. So if I measure this distance here, it will be 200. Then hit the escape button. Then if I will measure this angle here, it will be 30, which is the same as in here. And finally, you can measure this length, which is 200. It's very important to know that we don't need a center line all the time to mirror entities. Let's say I have a rectangle somewhere here, and I want to mirror it about this line. So select Mirror Entities. For entities to mirror, I want to mirror these four sides of this rectangle, and I want to mirror them about this line. So here we have a non-vertical or horizontal line, and we have a regular line, not a center line. Finally, you can add as many items as you want here, and you can mirror all of them at once. Another important thing to mention about mirror entities is that whenever you modify this entity, its mate here will be modified. Like if I drag this one will become the same. So basically, they are connected and they have some relations. Whatever happens here, happens here. Next, we will talk about linear and circular patterns. Linear and circular patterns. Let's start with a sketch on any plane you want. Let's start with a circle in the origin, and then give it a diameter of 100. Then you will find linear sketch pattern, select it, and here we can have many copies of this circle in both directions, the X and the Y. For the X direction, we have this basing. So since this is a 100 millimeter diameter circle, let's set this to 150. And you need to define the number of the instances. Let's say I want to have 10 instances. Then go all the way down until you find entities to pattern. We need to select this circle because it's the circle we want to pattern. And now we have 10 copies as we indicated here, and the spacing between them is 150. Hit OK. And here you have the copies. Notice that these circles are not fully defined. You can move them, but you can still have the same distance between them all the time. So you can simply define a distance here, let's say 150, and then all of them will be fully defined. Now hit Ctrl Z until you get here, then select linear pattern again. Let's set the same options, and now select this option, dimension X spacing, then hit OK. And here we have the dimension that we already did in the previous time manually. Once again, hit Ctrl Z until you get here and select linear sketch pattern again. Let's keep the same options. And now, instead of having the pattern only in one direction, we can have it in this direction. So for the Y direction here, you need to increase this number. Let's say we want 5 copies, and the distance between them should be 150. So now, the first pattern goes this way, and the second pattern goes this way. We can flip the direction of these patterns. For the X direction, you can reverse the direction from here. And for the Y direction, you can reverse it from here. One last option, if you go down, you will find instances to skip. Once you click here, you will have these points, and simply you just select the entities you don't want them to be shown after you finish the command. If I select this one, select any random 3 or 5 of them, then hit OK. And here you have it. Now I will hit Ctrl Z again and select linear sketch pattern. And once again, I will set the same options. And here, select this option. Now, hit OK. And we have this dimension listed here. Try to drag them. You can see they can't rotate. So this is the reason why we don't have a fully defined sketch. Now the solution is easy. You simply select this point, and then set them to be vertical. Now we have a fully defined sketch. Another type of creating patterns is circular pattern. Now hit Ctrl A, then delete. draw a circle somewhere here and give it a diameter of 25 and set this distance to be 100. Then select this point with this point and make them vertical. Now select circular sketch pattern, and here we need to define a point where this circle will rotate about. So in our case we need it to rotate about this point here, and it's listed here. Then for the entities to pattern, we want to pattern this circle. Make sure not to select this option for now, and the number of instances, I will increase it to 8, and now I have 8 instances. We have the option of equal spacing, which means this angle between this element and this one will be the same as the angle between any other two circles. Now hit OK, and here we have this pattern. Now, as you can see, it's not a fully defined pattern. Select this point and drag it. And here, the point of revolution doesn't lie in the origin. So simply select a small dimension and define a distance between these and set it to 100. And once you have this in the right position, place a length between them, and here you have it fully defined. Now let's hit Ctrl Z and once again select circular sketch pattern. I want this to be the origin, and for the instances I want these. Now we have equal spacing. Remove this option, and the angle between these is 90. Let's set this to 45. So we have 4 instances, and the angle between each instance and the other is 45. So this angle here is 45, and this one and this one. They are all the same. And you can increase the number of instances and reduce this angle. And here's the result. You can add this option, dimension radius, and let's see what happens. Here we have another dimension of the radius. We already defined this one, but this one was added from the pattern. So you need to delete one of them and simply try to drag any of these, and notice how this point doesn't lie in the origin. So select this point and the origin, then select make coincident. And here you have it fully defined. Now once again hit Ctrl Z and then select circular pattern, and the last option I want to talk about is instances to skip. We can skip any instance we want. You just need to select it, then hit OK. And here we have this pattern. Next, we will have a sketch practice. Practice 1. Here we will sketch this drawing. Let's start with a sketch on the front. Whenever you want to sketch something, it's very important to decide which point is the best point to start with. You can decide that based on the shape and based on the given dimensions. In our case, I think this is a good starting point. And we will go counterclockwise this way. We will sketch this drawing by 2 ways, and we will see the difference between them. So we will start with a line, and the length is 60. Then we have 40, 40, 40, 40, 40. and we have another 40 here, and as you can see, we have a fully defined sketch until now. Then we have the same story here. And then we have 60, 60, and 45. This one is 60, and by default, this will be automatically calculated. If we want to double check this one, we can place it, and now this dimension will be driven because it's not needed, but you will only be able to see it. And notice how it's grayed out. Now we have a fully defined sketch, but this is not a practical way of doing this, because you don't want really to place every dimension you find. We should use some relations, and instead of drawing it line by line, we should draw some profiles, then install relations and dimensions. Now, let's use the other way, and then you can compare the difference between them. Hit Ctrl A, then delete. The first line we have here is 60. Now, after that, I usually prefer to place the first dimension because this will fix the scale of the screen. Like, if you draw a line and then started to sketching all of these, then you started to place the dimensions, who knows, maybe the line you created is 1000, not 60. So imagine what will happen when you set it to 60. Then modifying the geometry will be relatively hard. That's why always place the first dimension, then start working. Now, what we know here is that these lines are equal, all of them. So, I don't want to draw it line by line now. I will draw a profile, something like this. And now I will set some relations. If we go back here, this point and this point are vertical. So, I'll select this point and this point, then make vertical. Now, basically all of these are equal. So select all of them, then make equal. Now, the length is 40. And as you can see, only with 2 dimensions and with the help of some relations, we have this fully defined sketch. Then, draw a line here and another one here. And if we go back to the drawing, this line is equal to this one. So, select this one, hold Ctrl, and this one, then make equal. And this is the second way of creating this sketch. Now, what's good about that, since we have some relations here, if you modify this, everything will be modified automatically. And this is the point of having a parametric design. Next, we will have practice 2. Practice 2. In this practice, we will sketch this drawing. Before we start, let's try to analyze what we have here. Here, we have this rectangle, and the dimensions are 200 by 120. If we have a look at this circle, we can tell that it's connected to this edge and to this edge. So, if I have this rectangle placed, I can place this circle easily. And the same story goes here. I have this half circle, and it's connected to this rectangle by this distance and by this one. And the same story is here with this slot and with this one. So our start will be with this rectangle. Let's start with a sketch on the front, and here select corner rectangle and draw a rectangle. I need this to be 200 and this to be 120. I have a circle somewhere here, and I have these distances. And this diameter is 25, and here I have a fully defined circle. Then I have another circle here, then snap to the quadrant point and connect these 2 points, then select trim entities and trim this part. Let's go back to the drawing, and here this distance is 25, and this one are the same. So this will be 25, and this one will be 25, and this one will be 25. Instead of defining this distance, let's delete this one, and here you can select this point, hold Control, select this one, and then make vertical. And here we have it fully defined. Then we have a slot here. The length is 50 and the width is 24. So pick a straight slot and draw it somewhere here. And here I need this to be 50. And I need this distance to be 24. As you can see, it's not fully defined yet because we can move it in the X and we can move it in the Y. So in the X we have this distance, which is 25, and in the Y we have 35. And here we have it fully defined. Then we have another slot here, but in this case I prefer to use another type of a slot, and it will be center point straight slot. Now make sure to set this line to be horizontal, and this is 24 and this is 50, so basically it's the same. And we have this to be 60, and obviously it lies in the middle because we have this 100 out of 200. So this line will be equal to this one, and we need to set this distance to 24 and this distance to 100, and finally this one to 60. The last thing is that we have this triangle. Obviously these sides are equal and the length of any one of them is 25. This point and this one are vertical, and we have this offset here. So there are many ways to draw this, but I will select polygon and I will set this to 3 sides and make sure to select inscribed circle. Now draw any polygon somewhere here, and after that set this to 25 and select this line and make it horizontal. Then select this point, hold Control and select this point and make vertical. And that's why I draw a center point straight slot, because I want to use this point. Now set this distance to 15, and here we have a fully defined sketch. Next we will talk about sketch practice 3. Practice 3. Let's analyze this drawing before we start. As we can see, we have 2 circles, we have two slots here, and we have two slots here. They are connected by lines and arcs. The lines are horizontal, and we have tangency between lines and arcs, and between arcs themselves, and so on. And we have some kind of symmetry in this drawing. If we have a look here, the drawing is symmetrical about an axis here. So the circle is the best starting point. We have a diameter of 20 millimeters and another one of 40 millimeters. Now, if we have this slot placed, it will be easier to connect it with these lines and arcs. So the distance between the center of this circle and the center of this slot is 80. And the slot itself is 50 millimeters in length and 20 millimeters in width. So let's pick a center point straight slot, make it vertical, and now let's set some dimensions. This is 50, and this radius is 10. And if you go back here, this point is horizontal with this one. And that's why we placed a center point straight slot, so we can use this point. Now, select this point, hold Control, and select this point, then make horizontal. Now the distance between them is 80. And here we have another slot, and the radius is 20. So we need to offset this slot with 10 millimeters. So select Offset Entities. Make sure to select Chain, set this to 10 millimeters, and then select this slot. Then we have another one here, and then set this point with this one to be horizontal, and let's see the dimensions. So this is 100 and the width is the same. And finally we need to offset this one, and the distance between them is 80. Now we have a fully defined sketch. The only thing we need to know is to connect these slots and these circles. Let's start here. We have a straight line, then an arc, it's tangent here, and we have another arc which is tangent to this one, and then we have another line and it's tangent to this arc. This length is 28. Let's start with a line, then snap to the quadrant point of this arc, make it horizontal, and then select Tangent Arc. Start here, click, and draw another one, and then pick a line and draw it something like this. Now, select this line and make it horizontal, then make it tangent, and make another tangency here. Then select this point, hold Control, select this arc, and then make coincident. We already know this length, which is 28, and it's equal to this one. And now, as you can see, we still have this degree of freedom, so we need to set these two arcs to be equal. And here we have fully defined segments. Now we need to repeat the same thing here. So basically, we have a line, then a tangent arc, another one, and then we need a straight line. So there's no need to repeat everything we did here. That's why we need to draw a center line and then select mirror entities. And for the entities to mirror, I want to mirror these. And I want to mirror them about this center line. Then hit OK. And here we have a fully defined sketch. Next, we will talk about sketch practice 4. Practice 4. Before we start, let's decide which one is the best starting point. In this case, it's obvious that this shape is symmetrical about an axis here, and it's symmetrical about an axis here. So this point is the best starting point. Now we have a polygon. It's a 6-side polygon, and the length of this side is 30, and obviously this side is horizontal. So let's start with a sketch, and then we need to place a polygon and set the number of sides to 6, and the circle should be inscribed, and hit OK, and start at the origin and draw any random polygon. After that, let's set this length to 30, but you need to zoom in to make sure that you place the length of the line, not the horizontal projection. That's why you need to move the mouse a little bit closer to the line, and here set it to 30. Then we know that this line is horizontal, and here we have a fully defined polygon. Now let's create this part here. We have two circles, and the distance between this point and this circle is 80. The first radius is 25, which is for this arc, and the diameter of this circle is 25. So let's draw two circles here, and then set this point with this one to be horizontal. This diameter is 25, and this diameter should be 50, since the radius of the arc we will have here is 25. Finally, this distance between them is 80. This arc is a part of a big circle here, and the radius is 40. So let's draw a circle, and let's set this diameter to 80. And here we have an arc, and the radius is 30. So let's start with a 3-point arc, draw any random arc somewhere here, and then select the arc, hold Ctrl, select the circle, and make tangent, and you need to do the same here. Then this radius is 30, and we need to trim these segments. So select the trim entities, and trim these. After that, we need to mirror this arc. So let's draw a center line somewhere here, and then select mirror entities, and then select mirror entities and select this arc and this center line. Here we have a straight line. The height of the extension of the line is 80, and it's obvious that this point is vertical with this point. So let's draw a line, set it to be tangent with this circle, and set it to be coincident, and then set this point with this point to be vertical, and this height should be 80. Now we need to mirror this line here, so select mirror entities, select this line, and mirror it about this center line. After that, we need to draw another center line here, so we can mirror all these segments on the other side. So select mirror entities, and select all the items we have here, and mirror them about this center line. we need to trim this segment and this one. So select trim entities and trim this one and this one. Here we have a radius of 40. So instead of drawing an arc, we can use fillet. So select fillet and set this to 40, and then select this point and select this one, then hit OK. And here we have a fully defined sketch. Next, we will talk about sketch practice 5. Practice 5. In this practice, we will sketch this drawing. The best start point is this point, which means we need to draw this circle. The diameter is 80. Then we have a line here and another one here. So snap to the quadrant point, draw a line, and draw another one. Now this line is tangent to this circle, and this radius is 20. So simply we need to fillet this, and the radius should be 20 millimeters. This height is 90, and this length is 90 plus this offset, which is 10 millimeters. So we have a 90 millimeter line goes this way, and a 100 millimeter line goes this way. Then we have these lines, and the offset is 10 millimeters. We cannot use the offset command here because we have a fillet here, but we don't have it on this side, and the same happens here. So we need to do this manually. Now these 2 points are vertical, and the distance between them is 10 millimeters, and the distance between these lines is 10 millimeters, and this line should be horizontal, and the distance should be 10 millimeters, and these 2 points should be vertical, and we need to connect these 2 points. Now we have a fillet here of 20 millimeters. So now we have the shape starting here up to here. Now we need to draw these lines, and the offset between them is 10 millimeters. Let's drag this here so we can see the lines. And now let's start with a line, and we can offset this one now with 10 millimeters. Then hit OK, then trim entities, and we need to trim this part and this one. Now, since this shape is symmetrical, we need to mirror this part we just created. To do so, we need to draw a center line here, and then select mirror entities and select these entities. And then select this center line. Then hit OK. And here we have it. Now we have this arc. As you can see, it starts here and it ends here. And the radius is 172.05. Let's pick a 3-point arc. And then this is 172.05. Now we need to place this slot, but before doing so, it's very important to recognize the center point of this slot, which is here. The angle is 60, so we need to draw a center line. Let's snap to this point. And this angle should be 30. And we need another line, or simply we can mirror this line. So select mirror entities, select this line, and mirror it about this line. And now let's select center point arc slot. Snap to this point, then here, and here. If you have this problem, you simply select these 2 points and set them to be coincident. Now this radius is 20. We will face some problems if we trim this segment because it won't be connected here and here. I'll show you how. If I trim this, as you can see, this slot is no longer fully defined, and I don't want that to happen. So I will hit Ctrl Z. I will turn this into construction geometry and simply pick 3-point arc, and I will snap here and here. And finally, select Mirror Entities, select this arc, and mirror it about this line. Let's hide the dimensions. And here we have a fully defined sketch. Next, we will talk about Sketch Practice 6. Practice 6. In this practice, we will sketch this drawing. If we have a closer look, the best starting point is this circle. As you can see, this diameter is not given, but if we have a look here, this is 22, so this should be something around 20. And here we have this arc, and we have this arc, and obviously they share the same center point, which is here. If you have a look at this dimension here, it goes all the way up to the center. So the radius is 30. That's why I will draw a circle, and this diameter should be 60. Then we have this arc, and the distance is 40, and the diameter here is 10. So I'll simply draw another circle. This should be 10, and this distance here should be 40, and this point and this point are vertical. Now, snap to the quadrant point and draw a line. And here, the distance is 50, and this distance is 8.5. So this distance here is 50, and this length is 8.5. After that, let's draw a central line here, and select mirror, select these 2 lines, and mirror them about this center line. Then we have this arc here, and the center of this arc is the same as the center of this circle. So the radius here is 25. I'll draw a circle, and this diameter should be 50. And now, start here, and let's say draw a random line and make it tangent, and then select the end point, hold Ctrl with this circle and make it coincident. Now select Mirror Entities, and let's mirror this line. After that, I have an arc here. Draw any arc for now, and then if we go back here, it's obvious that it's tangent here and tangent here. So we need to select this arc, hold Ctrl and this line and set them to be tangent, and here we have it fully defined. After that, we need to draw this part. This distance is 22, and from the center it's 17.05. So here I'll pick a midpoint line and I will draw it somewhere here. Then set these 2 points to be horizontal, and this distance here is 17.05. The length is 22. And now select a line, and you need to connect this point to this line here. And make sure this line is horizontal. And you need to do the same, but this time here. Once you're done, select Mirror Entities and select these 3 lines and mirror them about this center line. Finally, we have this arc and these lines, and they are the same as what we did here. So draw a center line somewhere here, and now select Mirror Entities and then select this line, this one, these elements. We forgot to trim this, but we can do it later. It's not a problem. Then about this center line, and here select Trim Entities, then trim this part, and trim this part. And we need to trim the circles, so don't forget to zoom in and to trim this part here, and to trim this part here. If we go back, this should go all the way until it touches this line. So here, select this line, then hit delete, and draw a line, connect this point to this line here. And you need to do the same. But before doing so, trim this part, then pick a line and connect these. Let's hide the dimensions. And here we have the drawing ready. Next we will talk about sketch 7. Practice 7. As you can see, we don't have a lot of dimensions. We only have this dimension and we have this node. So we need to analyze the relations we have so we can sketch this drawing. First we have this polygon. It's a 5-side polygon and the side length is 50. Then, starting from this point, we have this line and it goes all the way up to this point, and this one goes all the way up to this point, and so on. Then this circle touches the intersection point between these lines. And after that we have this arc, which is half a circle, and that means the center of this arc lies on this line. This information will be enough to sketch this drawing. Let's start with the polygon. It's obvious that this line is horizontal. And now we need to trim these parts. And then sketch a circle. And make it coincident with this point. Finally, we have an arc here. And then this point is coincident with this line. Then select a circular sketch pattern And for the reference point, it will be this point. And for entities to pattern, we want to pattern this arc. The total number is 5, then hit OK. And here we have a fully defined sketch. As you can see, it's not necessary to have a lot of dimensions to sketch such a drawing. You only need to be able to analyze all the relations you have in the drawing. Next, we will talk about overdefined sketches. Overdefined sketches. So far, we talked about two types of sketches: underdefined sketches and fully defined sketches. The sketch we see here is fully defined because all the lines are black, and you can tell from this note here. If I delete this dimension, then we have this blue one, which means the sketch is underdefined. Now we will talk about a third type, which is overdefined sketches. Usually we have such a type of a sketch when we have a problem or when we have a conflict. To understand this, let's analyze the relations we have here. Let's talk about this line and this one. To start, this line is vertical and the length is 50. And it's parallel to this one. And the distance between them is 100. So this line cannot have an angle here. The same applies here. This line is horizontal and this one is horizontal. They are parallel and the distance between them is 50. So now imagine what will happen if we make this line vertical. There will be a conflict. Now let's see how to overdefine a sketch and how to deal with it. If I try to place a dimension here, before doing so, we know that this line is equal to this line in length. So when we try to define a dimension here, this will cause a conflict. When you try to place this dimension, you will have this message saying adding this dimension will make the sketch overdefined or unable to solve. Do you want to add it as a driven dimension instead? So the first option is to make this dimension driven. Let's see this option. Here, as you can see, this dimension is grayed out, which means it's a driven dimension. It cannot control this length. The only purpose of it is to be able to see this value. For example, if I modify this to 120, this one will be modified too. If you try to modify it, it cannot be modified. So this is the first option we have. The second one is to select leave this dimension driving, and in this case we will have this conflict. And here, if you have a look, we have an overdefined sketch. Now there are many ways to deal with this. The first one is to select overdefined, and here you can diagnose this problem. SolidWorks tries to predict some solutions. So here we have 6 solutions. The first one is to delete this relation we have here, which is the horizontal relation. The second one is to delete this vertical. So this point, for example, can stay here, and this one can be here. So by having this line non-vertical, this problem can be solved. The third one is to delete this horizontal relation. The fourth one is to delete this dimension here. The fifth one is to delete this one. And finally, to delete this vertical. Let's try any of them. For example, let's delete this one, which is the vertical. All you need to do is to select accept. Now we have this message. The sketch can now find a valid solution. Hit OK. And now what happened is that this line is not vertical, even though you see it vertical. To prove this, I will modify this to 150. And now you can see that this line is no longer a vertical line. So this was a solution of this problem. Now I will turn it into vertical once again, and this will cause the sketch to be overdefined once again. The second way to deal with this is to deal with it manually, using manual repair. Select it here, and you will have all the relations and dimensions listed. Simply, you can select any of them, and then you can delete it. For example, the same solution. If I select this vertical, you can select delete, then OK, and here we have a fully defined sketch. If I draw a line here, obviously this line is not vertical and it's not horizontal. So what happens if I set this line to be horizontal? Now I have this red item, which means item is unsolvable. To solve this problem, we have these options here. The difference here is that the red items must be deleted so you can solve the conflict. If you try to delete this relation, for example, it won't solve the problem. As you can see, there's no way for this line to be horizontal even though we already deleted this relation. So the only solution we have here is to delete this relation. So select this relation, then hit delete, and once again set this line to be horizontal, and here we have our fully defined sketch. So this is how we deal with overdefined sketches. This completes this section. In the next section, we will start talking about 3D modeling by talking about sketch-based features.